Ladies and gentlemen, you ready?
Yeah.
All right, let's talk about proofs. Franklin, what do you want to talk about?
Number 8.
Number 8. Okay, the actual proof. I will go over that. Okay, we'll probably go over all 3 of those. But let's first, 1 through 7, any of those you weren't sure about? Those were just asking you to provide a theorem that would be like a justification. So someone tell me, what was your answer for number 3? Number 3, Noah? That's right. 3 and 6 form a linear pair. And so we know they're supplementary because they're the linear pair theorem. And so what the linear pair theorem says is if you have angles that are a linear pair, then those angles must be supplementary. Okay, that angles that form a linear pair are supplementary. So look at this connection. We have angles 3 and 6, which are a linear pair, and we can conclude that they're supplementary because of that linear pair theorem. Okay, Jackson?
6 and 7.
Problem 6 and 7?
Yeah.
Okay. What do you have down for number 6? Jake?
Corresponding.
Okay. This is the corresponding angles postulate.
I got the same thing for 7. I was just wondering if that's right.
It is. Okay. Now let's talk about why that's true. The corresponding angles postulate could actually be written as a biconditional. Okay? Actually, all of those theorems we've been talking about, the alternate interior angle theorem, the alternate exterior angle theorem, you could reverse it, meaning you can say if 2 lines are parallel, then corresponding angles are congruent. Or you could say if corresponding angles are congruent, then the lines must be parallel. So technically this one that's written backwards, see how this is concluding with the lines being parallel? That's technically the converse of the corresponding angles postulate. But we're not going to get too bent out of shape about that. As long as you know that it's the corresponding angles postulate as well, that's fine. Hunter?
Is number 2 linear pair theorem?
Well, let's see. Angle 1 is equal to angle 3. So are angles 1 and 3 a linear pair? Okay, a linear pair are angles like 3 and 6 that are right next to each other and form a straight line. See how 3 and 6 form a straight line? 1 and 3 do not. What kind of angles are 1 and 3? I see where you're getting same side from. They're not same side, they are, I heard it back here. Okay, they're not alternate because they're not on different sides of the transversal. Matt? They're corresponding angles, just like these ones are down here. They're in the same position. If I picked up these 4 and laid them on top of these 4, the 1 and the 3 would line up. And so this would also be the corresponding angles postulate. Okay, let's go down to number 8 and talk about this one. This is a proof, and what you're trying to prove, and not everything you're going to prove is technically a theorem. You can prove any statement that's an if-then statement. So you're trying to prove that if we know these lines are parallel, and we know angle 1 is congruent to angle P, then angle 2 must be congruent to angle P as well. Okay? So again, the first step of your proof is really easy. We just restate the given. So I'm going to restate M is parallel to N, and angle 1, hard to squeeze in there, angle 1 is congruent to angle P. And my justification for that is that's my given. That's the hypothesis of my sentence. Okay. And what I usually do at that point is I take whatever information I just got in the given and I mark it in my picture. So I'm going to mark that these 2 lines are parallel. And I'm going to mark that angle 1 and angle P are congruent. So these 2 angles are the same. And remember, what I'm trying to show is that angle 2 is also equal to angle P. So I'm kind of stepping you through here. My next step would be to say that angle 1 is equal to angle 2. How do you know angle 1 is equal to angle 2? Caleb?
Because they're alternate interiors.
Yeah, alternate interior angle theorem. Okay, that's why I know that. So now I know that angle 2 is also equal to angle 1. So now if I have angle 1, and I'm just rewriting this down here so you can see it a little more clearly. Up in the first step I said angle 1 equals angle P, and then I said angle 1 equals angle 2. So how do I know these two are equal to each other? Do you remember the name of that property? We talked about it yesterday. Is that Laura's hand back up there? That's the transitive property, yeah. Transitive property.
Is there an abbreviation for that? Trans?
I guess you could do trans, sure. Okay. So the transitive property is anytime you have two things that are equal to the same thing, they must be equal to each other. Okay, that's what the transitive property says, and that comes up a lot in proofs. Okay, you can prove two things are equal by proving that they're both equal to something else. Brooklyn?
Will you ever give us one like that we try to prove right when it's wrong?
No.
Okay.
No. I might give you a statement and ask you whether it's true or false, but I would not tell you to write a proof and then have it not be one that you could actually prove.
Okay.
So, good question. I'm not that mean. But. Okay, how about on the back? Do you want to just go through 9 and 10 together? Okay. Well, actually, number 9, you just had to give justification. Well, let's go through number 9, just to make sure we're... Okay, so given that Q is parallel to R, so I'm going to restate my given, and then I'm going to mark that Q is parallel to R. How do I know angle 1 is equal to angle 2? Hunter?
Because it's vertical.
Vertical, yep. Ladies, can you stop talking, please? Thank you. It's the vertical angle theorem, which I don't know if I showed you this yesterday, but I abbreviate it this way, vertical angle theorem. Okay, that. You can write vertical angles too, as long as you know it's because they're vertical angles. I'm good. Hunter? The next one? Okay, how do we know 2 is equal to 4 in this picture? Preston? They're corresponding angles, yeah. Corresponding angles postulate. Okay, so now we know 2 is equal to 4. And so now if 1 is equal to 2 and 2 is equal to 4, how do I know 1 is equal to 4? Jake? Okay, great point. Technically, we could have said 1 is equal to 4 straight from the get-go, right? We are trying to prove this is true. This is actually a proof of the alternate exterior angle theorem. It doesn't say that. I wish it said that. Yeah, I would use the transitive property. Yeah. And then what you can say after that is that now we know alternate exterior angles are congruent. Okay? So yeah, there is an alternate exterior angle theorem, and this is the proof of it. This is why it works. Because you can take these angles and say, well, these are vertical and these are corresponding, so these must be equal. Okay? Someone asked me yesterday, why aren't the other angles numbered? I would assume if I hand you a picture and I only have certain angles numbered, those should be the only angles you have to use. Okay? Now, if you're drawing your own picture, that's another story. But if I hand you a picture without all the angles numbered, because remember, there's a lot of statements we could make about this picture. We could start saying 2 and 5 are supplementary. 3 and 4 are equal. Okay, but you want to make sure that the statements you're saying are leading you in the direction of what you're trying to prove. So that's why we sometimes narrow it down for you. Okay, so in number 10, given that P is parallel to M, that's my given. Okay, so this and this are parallel. Now technically 7 and 6 are alternate interior angles, right? So this is really a proof of the alternate interior angle theorem, which we did yesterday. You actually have this written down someplace. How do I know 7 and 5 are congruent? 7 and 5. What kind of angles are 7 and 5? Oh, they're corresponding. Yep. Corresponding angles postulate. Okay, so 7 is congruent to 5. And then my next step, I'm telling you that I want you to use vertical angles. And the thing is, there's a lot of different pairs of vertical angles in here. But I want you to look at what we're trying to get to. We're trying to get to angle 6. All right, we need angle 6 in there somewhere. So tell me, what set of vertical angles would I want to use? Yep, Noah. 5 and 6 is what I would use, yep. 5 is congruent to 6 because of vertical angles. And that lets me go from 7 to 5 and then 5 to 6, so that must mean 7 is congruent to 6. And what's the name of that jumping property? Transitive property, yep. Okay. Anything 11 through 14 that you need help with? Feel pretty good on those?